Hey fellow YouTubers, this is N0AGI. This is the part 3 of my NIXIE tube tester project. So I was able to do a skeletal view of my NIXIE tester here. So as you can tell, I have one of these, let's see if I can get that. There are about, whatever, 49 of those over there, and there's one over here I'm using for testing. So I hooked up this NIXIE to my DC to DC booster circuit that you've seen in my previous video, and I'm only supplying 9 volts to it, and I have about, I think it was a 12K I used, so let me see if I can get a closer view here. There's a 12K on the positive anode that's hooked up to my NIXIE here, and then these wires here are all going to my the binary to decimal driver that I had covered briefly in my one of my previous videos. Let's see if I can show that to you. So there's about 99 or so of those in there. But anyway, so let me quickly explain. I won't go into too many details, but I'll try to cover at high level as I can. There are 3 stages in my tester as we speak. The first stage is driven by the 555 timer, and it puts out a pulse. And the pulse is then fed into this binary counter. The binary counter drives the 4-bit LEDs here, and it's configured like I described in my previous video. The counter is configured to reset after 9, so it counts up to 9 and then resets itself, because for my NIXIE tube all I care about is from 0 to 9. So and you can tell that once it reaches 9, it resets and goes back to 0. And then the counter then feeds the output into the NIXIE driver chip. Let's see if I can focus that. The NIXIE driver chip. The NIXIE driver chip then converts the binary to decimal, and the decimal then output is then fed into these purple leads back into the cathode legs of this NIXIE tube. So this NIXIE tube, as I was sharing in my previous videos, has common anode, and it's driven by 170 volts. I think I might not be running at 170 at this time, because not only do I only feed 9 volts to it, I think this should work with 9 volts, but it's rated for 12 volts. I'm also limiting the current with the 12K resistor, so I need to go and measure exactly how much is being fed to the NIXIE tube. So let me I can post these PDFs on my description section on this video. This is a one-pager that describes the layout of the NIXIE tube. Let me see if I can get a closer view of it. And it basically describes the layout. So this is viewed from the bottom, right? And that shows you, this is a 12A. The difference between 12A and 12B is the decimal point is not connected or not used in 12A. So what I have here in my project is a 12A. But anyway, so and here it lays out which of these pins corresponds to which digit. The anode pin is marked with a white marker, like I was sharing in my previous video, in the back, so you can easily locate that and then these are the, for example, pin 2 is 0, pin 2 is 0, pin 3 is 9, etc. So they're not in sequence. So just, this is important to note that these are, the pin numbers do not correspond to the corresponding number, so they are different. All right, so that's the NIXIE tube layout, and you can tell from here it's rated for 170 volts DC, and it's rated for 170 volt supply, 170 volts DC minimum. But I doubt that I am supplying that much of voltage, because the reason why I think that is the case is when I first tested the NIXIE tube, I don't think I was drawing that much current, so I need to go back and look. Anyways, and the decimal point draws much lower. Of course, in my case, that's not applicable. The current draw is rated at 2.5 milliamps for numbers 0 through 9. And here's the layout of the K155ID1, the NIXIE tube driver chip that converts binary to decimal, and I'll post this also. And so the way this is, let me quickly talk about that. The VCC is 5 volts. Basically, what I've done is my benchtop power supply, this side of the power supply produces 5 volts, and that goes into my timer, it goes into my counter, it also goes into my NIXIE tube driver, right? So that's 5 volts. So what you do is you hook up the pin number 5 on your driver chip to 5 volts, the same 5 volts that you've used for your other stages of your circuit, and the ground goes to ground. And then what you also need to do is make sure that you take the DC to DC boost circuit ground and hook that up also. Let's see if I can get this to focus here. And hook that also to the ground, right? So it's a common ground. All right. So outside of that, again, same thing applies here. It's marked as outputs, ground, outputs, and there's input here. A is bit 0, B is bit 1, bit 2, and bit 3. Okay, or you can count it 1, bit 1, whatever, right? 4 bits. And then the outputs are also spread across, so it's not like the pin doesn't correspond to the number, so you need this data sheet to be able to successfully understand how these pins are laid out and for which digit. All right, so with that, thanks for watching. My next step is to I'm gonna make a PCB, a homebrew PCB, and I'm gonna transfer this over onto it. And what I'm planning on doing is, once I've done that, I'm looking at transferring. I went to the local Axeman store the other day and I bought these enclosures. These enclosures are pretty slick, actually. These are, I think I paid $2 for each. This is another enclosure. I paid $4, I think this was. But check this out. This was very intriguing, so I picked one of these. I digress a little bit, but I got this at the same Axeman store. I paid $4.95. This is a full metal enclosure. I think it was used for some sort of a RF application, And the way this works is it comes with nice caps on it. These are also metal caps. And you open the case, and it's got a nice metal casing in here. I'm thinking of using this to make my NIXIE tube tester enclosure. So should be a fun project to do that. So I'm waiting on a shipment from USPS postage, the carrier board for the NIXIE tube that I will be mounting on here, and then I'll be moving that circuit into this box and get this all wired up, etc., etc. So that'll be another YouTube video, I think. Anyways, hey, thanks for watching, and I'm definitely learning. Very excited about electronics, to spend some quality time. I always did some electronics in bits and pieces, but I never really sat down and carved out some quality time to learning electronics. So I'm doing that in the last a few months now, and so a lot of this stuff is relearning what I had learned when I was much younger. So definitely enjoying it. So by the way, this is my electronics workbench, that side of the lab. That's the LaCroix DDA 125. That's my NIXIE tube counter. That's another counter. That's a Siglent function frequency arbitrary function generator. Another counter, etc., etc. So, and then on this side, that's my ham radio side of the business end of it. And let's see, so that's the ham radio stuff, and that is the electronics lab section. Well, thanks so much for watching. We'll talk soon.